This video is on triangle theorems. What is it called when you connect one midpoint to another midpoint in a triangle? This is called the triangle midsegment theorem. It states that if a segment joins the midpoint of two sides of a triangle, then the segment is parallel to the third side and half as long. So what that really means, if we come over to this figure to the side, we have a triangle where we have tick marks showing that we have midpoints. Because this tick mark shows that segment AD is congruent to segment DC, we actually have midpoint at D. We also have that segment BE is congruent to segment EC because of those tick marks. Therefore, point E is the midpoint of segment BC. And therefore, DE connects the midpoints of the two sides of the triangle. That makes DE the midsegment of the triangle. So come over here back to the theorem. It states that if the segment joins the midpoint of two sides of a triangle, so we have that. DE is connecting the midpoints of the triangle, of the two sides of the triangle. Then the segment, so that same segment, DE, is parallel to the third side. So let's come over here. So it states that segment DE is parallel to the third side, which means that it's parallel to segment AB. So we can actually use the symbols for parallel, those arrows on the segments, states that those are parallel. Now the reason why we want to know that they're parallel is because with parallel lines cut by a transversal, we have corresponding angles, alternate interior angles, same side interior angles, all those different 5 relationships between parallel lines and transversals. Those can help us if we're needing to find angles. Now it also states that then the segment is half as long. So the segment is parallel to the third side and half as long. So we actually know how long, if DE is actually half as long as that third side. So we can say that DE is equal to half of the length of AB. Notice I did not put the segment symbol on top because we're dealing with lengths. That's if we have the length of AB, we can take half of it and say that's DE. But what if we have the length of DE? DE is actually, if we multiply DE by 2, if we double DE, we can actually figure out the length of AB. So if we want to know what AB is, we can take AB and it's equal to twice the length of DE. Basically, if I were just to multiply by 2 on this side to get rid of the fraction, I'd end up with this. So it means the same thing. So again, if we have a segment joining the midpoint of two sides of a triangle, then the segment is parallel to the third side and half as long. So we actually have 2 parts to the theorem. If we have the first part, then we can state the second part. But if we're given the second part of the theorem, we can actually state the first part. That means we would have midpoints. So we have a couple of examples down here. So the first example says solve for x and the missing side lengths. So on this triangle, we have a triangle sitting inside of another triangle. We do not have tick marks showing that we have midpoints. But we do have parallel sides because we have these arrows. We have 2 arrows on this side and 2 arrows on that side, meaning these 2 are parallel, and we know the lengths of those. We actually have that 6 is half of 12. So again, going back to this theorem, if we have the second part, the segment is parallel and half as long, that means that we can state the first part. So we actually have the second part of the theorem. So actually, I'm going to come down here and write a note. We have parallel and half as long. We have that because we have the arrows and we have the measurements of the third sides. Therefore, this little symbol, it looks like 3 dots forming a triangle. This actually stands for therefore. So if you see this again, it means that we can state something else. Therefore. So since we have the second part of the theorem, we can state the first part. That means we have midpoints. That means that we can actually prove that. We can say that we have midpoints. So we will have midpoints. So if we go back up to the picture, it's not going to be midpoints of the third side. We know we're going to have midpoints of the other two sides because we're connecting the midpoints. This mid segment right here will connect your midpoints. Therefore, we actually have a midpoint here because we have two congruent sides. This is where your midpoints would be. So we have two congruent segments here, and that means we'll also have two congruent segments here, but we have to use two different tick marks because they're not, this length is not actually congruent to this length, or we don't know if they are. But now since they're congruent, we can set them equal to each other. So we have 2x plus 4 equals x plus 9. Subtract the x, we get x plus 4 equals 9. If we subtract the 4, we'll end up with x equals 5. Then we can plug them back in. We have 2 times 5 is 10, plus 4 is 14. So this length is 14. Then we have 5 plus 9 is also 14. So that is accurate that we did this correctly because these are in fact congruent to each other because they're equal in size. So this is a midpoint. So coming over to this next section, to this next example, again we're solving for x. This time we're not given the parallel and we're not giving any measurements on the third side, but we are given congruent tick marks, meaning that this segment here is congruent to this segment here, which means that we have a midpoint there. We also have 2 tick marks here and 2 tick marks here, meaning that these two segments are congruent, so that means that this is the midpoint. We do have a segment connecting the midpoints, therefore we have the mid segment. So I'm coming down here and making a little note. We have midpoints this time. Therefore, so I'm going to do 3 little dots. Therefore, since we have the midpoints, that's the first part of the theorem, we can state the second part, which states that we have parallel and half as long. Now, we might only need one of them, but we can state that we have both. So if we go back up to our picture, we can state that the third sides are parallel, so we can do our arrows, that they are parallel, and that they're half as long. But since we don't have any measurements on these values, on these segments, we don't need to know that half as long part because we don't have any numbers. But you can see that the x is actually a degree, so it helps, we need to know the angles. So parallel goes back to those 5 angle relationships. Corresponding angles, alternate interior, same side exterior, alternate exterior. We got to figure out which one is which. So on this problem, we have that x degree. I'm going to highlight that. I'm going to outline that x degree. I'm going to outline it. And then we do have that 71 degrees as well, so I'm going to outline that one. The reason we do this is we see that both of these angles, this pink right here and that pink right there, are actually both touching the different parallel lines. So that is very helpful in stating that we will probably have one of those 5 relationships. And we can also see that this part of the pink is touching the same line. That means that this is your transversal. So we have 2 parallel lines cut by a transversal. So where are these located? Where's the location of these 2 angles? The 71 is on the top right, so the top of the parallel line and right of the transversal. And the x is on top and on the right. So if these are in the same locations, just on different parallel lines, that means that we have corresponding angles. These are corresponding angles. And the numerical relationship is that they are actually congruent to each other. Therefore, since this is 71 degrees, x is also equal to 71. They're the same degree. On this last example, it says solve for the missing variables. We have x's and y's in this problem. So since there are x's and y's, we need to make sure we focus on the ones that will help us first. So as you can see in this picture, we have no parallel markings, and we also don't know what these lengths are, so we can't determine if they're half as long. But we do have tick marks, which will help us. So we have tick marks, one tick mark here and one tick mark here, stating that this point is a midpoint. We have two tick marks here and two tick marks here, meaning that these are congruent, stating that this is a midpoint of that entire segment. So you see how x is on a segment that connects midpoints? Therefore, we will have a mid-segment, and that will help us with the 3x minus 6, because that one goes along with the 3x minus 6. We also have 3 tick marks here and 3 tick marks here, so therefore these two segments are congruent, so we have a midpoint here. Now, this mid-segment has nothing on it, and the one that it would be parallel to also has nothing on it, so that won't help us. But we still have y is on a mid-segment as well, because we have these are connecting midpoints, which is parallel to this segment, to the third side, so we have a y and 2x plus 1. So those will go together. However, the y and 2x plus 1 go together, that won't help us yet because it's two different letters. But we do have the x and the 3x minus 6 going together, so that can help us. So I'm actually going to highlight that in blue because I want to focus solely on these right now, and I'll do the work in blue as well. I'm going to make a little note down here again. So since we have midpoints, therefore we have parallel and half as long. So that can help us because we can either use the half as long part or the parallel part. Parallel will give us angles, half as long will give us lengths. And in this case, we want the lengths because that's where x is located, on a length, not an angle. So if we look back up here, we have that the smaller side, the mid-segment, is half as long as the third side. But we can also state that the third side is equal to 2 times the little one. So if we look at this problem, we have an x and a 3x minus 6. So which one should we really use? Which one of these equations would be most beneficial? This one has a fraction in it. So it would be the little side is equal to half of the big side. So this is a little side is equal to half of the big side. Well, I would be taking half of 3, and that would still keep a fraction, so that might not be the greatest thing to do. But we could do AB, so the bigger side is equal to 2 times the smaller side. So the bigger side is equal to 2 times the smaller side. There would be no fractions. That would actually probably be the best one to use. So we could actually have the bigger side, the 3x minus 6, is equal to 2 times your smaller side, which is x. And now it's just solving for x. So if we subtract the 2x over, we have x minus 6 equals to 0. Therefore, we need to solve for x. X will equal to 6. So now we have 6, so we can actually plug them in and actually find values and lengths. So if x is equal to 6, we have 3x, which is 3 times 6 is 18, minus 6 is 12. This length is actually 12. We also have x here, which is just x, so this is 6. Now 6 is half as long as 12, so that actually works. But we also have an x here, which could help us because we still have to find the y. So if we know the x already, we can plug that in. So this is 2 times 6 is 12 plus 1. So this is 13. So when we do the y part, I'm going to highlight this in pink, the mid-segment, and then the third side for the y is here. So I'll do my work in pink as well. Now I will put it out with the letters as well. So we have, again, the little segment is equal to half of the bigger segment. Or we can say that the big segment is equal to 2 times the little segment. Now, since we're solving for y, it would actually be a little bit easier to go with this one, where it's y will equal to half of this. That way we don't have to get everything off of y again. So if I start with the little segment, the mid segment is equal to half of the third side. So y is equal to half of that third side, which was that 2x plus 1. But remember, we plugged in that x and we got 13. So we really have y is equal to 1/2 of 13, because we already plugged that in. Now, half of 13 is 13 over 2. We would actually leave it as that fraction. Y is equal to 13 over 2. So if this length is 13, this length would be 13 over 2, which is 6 1/2. So we could actually put that this is 6 1/2. 6 1/2, which is half of 13. So again, if you have the first part of the theorem that you have midpoints, then you can state that you have parallel and half as long. However, if you're given parallel and half as long, you have to be given both of those, then you can state that you have the midpoints. So it all depends on what you're given to begin with, and you can state the other half of the theorem.